All right, so let's have a look at the square root of a complex number. Now, to express the square root of the complex number a plus vi in the form x plus iy, where x and y are real numbers. All right, so our objective is to express the square root of a complex number as a complex number. That's our objective. Please note that x and y must be real numbers. All right, so we have been seeing that going forward, or going through the lessons, we have been seeing it, that the real part and the complex part, the real part and the imaginary part of a complex number, they are real numbers, because the real part does not include I, and I is actually the unit imaginary number. All right, so the way you would actually approach this is that you would sort of square both sides. So if I square both sides, I would end up with a plus bi. So if you square the root of a plus bi, it's going to be the root a plus bi multiplied by root a plus bi, which is a plus bi. Just like our root I times root I is, root minus 1 times root minus 1 is minus 1. So root a plus bi multiplied by root a plus bi is a plus bi. That is if you're looking at it from a point of view of surds. Now, x plus I y square is going to be x squared plus 2xyi plus y squared I squared. And everybody should be able to do that. It's simply binomial expansion. So this is going to work out to be x squared minus y squared plus 2xyi. Remember, our objective is to determine what are the values of x and y. Because if I know what x and y is, I can find out the square root of the complex number a plus bi. So the way we're going to work this out now, so these two complex numbers are equal. We're going to equate parts. So the real part, which is what? X squared minus y squared. The real part on the right is going to be equal to the real part on the left, which is a. And the imaginary part on the left, which is 2xy, is equal to the imaginary part on the left, which is b. So what we should end up with is two equations with two unknowns. Solve that equation and we get our answer. You should understand, but if you don't worry about it. Let's show it to you in action. And also, don't worry, I'm going to give you a chance to do it as well before we finish this evening or this afternoon. So example 9 says, express the square root of 5 plus 12i. Go ahead.
When you separated the equation, you said one is real and the other is when you have the x squared minus y squared.
What we have here at this level is we are saying that two complex numbers are equal. The complex number on the left is equal to the complex number on the right. Now, if two complex numbers are equal, their real parts are equal. So the real part on the right, which is x squared minus y squared, is equal to the real part on the left, which is a.
Okay, sir. I guess I just blanked out and wasn't listening.
But it's fine.
Okay.
And the imaginary part on the right, which is 2xy, is equal to the imaginary part on the left, which is b. All right, example 9, guys. All right, the technology just decided to give problem. So example 9, it says express the square root of 5 plus 12i in the form x minus iy. So exactly what we said, what we're going to do is what we're going to do. So this is 5 plus 12i. We're going to say that this is equal to x plus iy. Then we're going to square both sides. And if we do, we're going to end up with 5 plus 12i. 5 plus 12i would be equal to x squared minus y squared plus 2xyi. All right, so that's the first thing. So the next thing we're going to do is that we have two complex numbers and they're equal. The next thing we're going to do is that we're going to equate real and imaginary. Turning the page. So now I'm going to have x squared minus y squared is equal to 5. So the real on the left is equal to the real on the y. This is my equation 1. And 2xy, which is the imaginary part of the complex number on the right, is equal to 12, which is the imaginary part of the complex number on the left. This is equation 2. Now, all I have to do is solve these two equations simultaneously. So if I have 2xy is equal to 12, and I divide both sides by 2x, I'm going to get y is equal to 6 over x. So, and this is equation 2. Then I'm going to substitute this value of y in equation 1. So now I'm going to have x squared minus y squared, but y is 6 over x. Square is equal to 5. You have done things like this already at CSEC, so it is more tedious than difficult. It's sort of long, but it's not difficult. So what we end up with is we should have x squared minus 36 over x squared is equal to 5. Now I'm going to get rid of the fractions because I need to find out what value of x is, then I can calculate the value of y. I need to get rid of the fractions by multiplying. I'm going to multiply the entire equation by the LCM of the denominator, which is x squared. So x squared times x squared is, so let me spell it out. So it's x squared times x squared minus 36 over x squared times x squared is equal to 5 over 1 times x squared. I multiply the entire equation by x squared. This will cause me now to get rid of the fractions. That goes, that goes. I'm going to have x to the 4th power minus 36 is equal to 5x squared. Then now I'm going to bring over my 5x squared, and this is going to become x to the 4th power minus 5x squared minus 36 is equal to 0. Now, this is actually a quadratic. In order for you to see it clearly, I'm going to say let x squared be equal to a. So this is going to be a squared minus 5a minus 36 is equal to 0. So our objective is to find what a is. And once we find out what a is, we can find out what x is. Once we find out what x is, we can find out what y is. Once we know what is x and y, we will have the solution we'll have the square root of the complex number. So I'm going to do this by trial and error. I'm going to factorize. This is A. This is A. I think one has to be 9 and 4. The 5 is positive, so negative, so that is negative, and this is positive. All right, I'm assuming that you know how to factorize a quadratic expression by trial and error. So here, I'm multiplying 2 binomials and I'm getting 0. So it's either the first that is equal to 0, or the second, which is A minus 9, that is equal to 0. Therefore, A is equal to minus 4, or A is equal to 9. But remember, A is actually x squared. So therefore, I can say x squared is not equal to minus 4. But x squared is equal to 9. And so x is equal to positive and negative 3. And the reason I said x squared cannot be equal to minus 4, because in the solution, x and y must be real numbers. So now I know what x is. I could easily now come back to this, which is y is equal to 6 over x, to say that y is equal to 6 over 3, or y is equal to 6 over minus 3. So y is equal to positive and negative 2. Ladies and gentlemen, we started out by saying that the square root of 5 plus 12i, I said ladies and gentlemen, but it's just ladies, is equal to x plus iy. We now know what x is and what y is. So we can say the square root is equal to x, which is positive and negative 3. Or let's not write it like this. Positive or negative 3. Y is what? Positive or negative 2 plus 2i. And now we're at the end of the solution. Now all of that is the end of the solution. All right. Now I'm going to give you a chance to have a good look at it. Then I'm going to ask you to try one before we go.